Everyone, let's get started. Happy Friday. See folks greeting each other in the text chat. Great to see a large group here today. This is our last session for the Foundations of Statistics using R course for the online meeting. So congrats for making it this far. And this is the last one that I'm actually teaching until I see you in class in May. So I'm looking forward to our time today, our hour and a half, and I expect a lot of energy because R is fun, and we are, your work I've been reviewing over the past couple of weeks has been, really amazing. Everybody's been really on track, which has been very encouraging from a teaching perspective. So I hope that you're getting a lot out of the online sessions where we meet, live online, and also the ones that are asynchronous that you're doing at your own pace. Please give me feedback. I always appreciate it. And even during this session, if if I'm going too fast or too slow, let me know. We can try to kind of move things around. The last session, I like to do a lot of different things just so you get some exposure to some new concepts in R as well. And we spend a little bit more time on visualization. So what I like to do before we get into the content, like always, I like to do just a little roll call and make sure that you're kind of here and present. So I'm just going to call out your name, and I'm going to unmute everybody, and just make sure that you mute yourself now so we don't hear any background noise. I appreciate that. And then I'm just going to go down my list of folks that have registered and let me know that you're present. A few people need to still mute their mic, please. Okay, so I'll start with Charles Chan. Are you here?
Good morning.
Good morning. Okay, Cactus Razi.
Good morning.
Good morning. Welcome. Vinod. Vinod, are you here? Okay, let's move on. Amer. Gafar.
Right here, Professor.
Okay, thank you. Ajay. Nadia.
All right, sorry, I was on mute. Yep, here.
Okay, thank you. Aman.
Good morning.
Okay, good morning, Aman. Min Shen.
Morning.
Good morning. Shamika Brayton.
Good morning, everyone.
Good morning, Shamika. Okay, Angela Calabrese. Angela, are you here? Okay, great. Thank you in the text chat. Dimitri.
I'm here.
Okay, thank you. Jeff Bevan.
Good morning.
Good morning. Hanwen Alvin.
Good morning, I'm here.
Good morning. Bharat.
I'm here.
Great, thank you. Nande.
Good morning.
Good morning. Ahmad.
I'm here.
Ahmad. Bharat. Bharat, I see that you're here.
I think there are two Bharats. So.
Oh, I'm sorry.
Machineni, so yeah, I'm here.
Thank you. I was working on it. Okay. Atku?
Yes, I'm here. Hello.
I always say I have a very hard last name, so I really try to work hard. Ashay.
I am here.
Okay, thank you. Alex Q. See that you're here, Alex. Thank you.
Yeah.
Thank you. Linda Vo. Linda. I see that you're here, so maybe you're on the phone and muted. All right. Nicholas Vasilius. Okay, I don't see Nicholas. Saeed Kukar.
Good evening, I'm here.
Good evening. It's morning for me.
I know.
Akash.
Good morning.
Good morning. Chad Rothbart. Chad, I see you're here, but can't hear you. Let us know that you're here in the text chat. David Edwards.
I'm here.
David Rishi Doshi.
Hi, good morning.
Hi, good morning. Brian McGinnis.
Here.
Perfect. Tim Raiswell.
Hey, everyone.
Okay. Essel Madrid.
I'm here.
And Tyler Flint.
I'm here as well.
Perfect. Okay. So I hope everyone's doing well, and feel free to use, your mics more during the session. You don't only have to use the text chat. It's really great to hear your voice. I know only for a second, but just to kind of know that you're present. And I'm really learning your names. I think I'm getting better at some of the pronunciation, but please correct me because, like I said, my last name Sisolsky gets butchered all the time. Anything from Suzuki to something that doesn't even begin with an S. I don't know. So I'm very sensitive to it, and I like to get it right. So let's go on to the session overview. This shouldn't surprise you. The session overview for all of the online meetings has been the same. So the idea is that these are practice sessions. They're not meant to just be, full lectures, and to give you this opportunity to practice and build on your prior knowledge and skills. And whether your prior knowledge is from classes that you took before, or you're building on just your knowledge that you've learned in this class throughout the online lessons. And of course, I'm here to answer your questions. So along the way, please, if you have questions, don't hesitate. And also, please feel free to answer each other's questions. Everybody's been really fantastic at that. And I feel like this point in the course is just, my enthusiasm goes up even more because you're able to, do so much more than in the beginning with R, and these skills will really provide you with the foundation to do some really, really amazing things. And I wanted to take some time to illustrate what some of those things are, because we sometimes think, okay, we're using R as a calculator and, I'm able to do like some simple math, or I'm able to follow along with the lessons, but how does this really lead to anything that's real? And why don't I just do everything in Python or another language? And I want to continuously remind you and motivate you that this is just really the beginning of using R really as a tool, so then you can implement many different models for, say, your capstone projects and the like. One of the things that I do as a faculty member in the program is, and all faculty members, we could advise up to 2 capstone groups. And so I'm the advisor for, every year I'm the advisor for at least 1 capstone group. And my groups to date have done applications, actually built full applications in a package called Shiny, which is an R package. Has anybody heard of that? Or want to explain what Shiny is to the class? You also feel free to use your mic if you want to just explain it.
Hi, this is Tyler. Yeah, we use it here at my company, Micron. We deliver a lot of our solutions through Shiny. So our HR data science team, for example, has a lot of reporting and detailed visualizations on our HR analytics that go through Shiny. And on the team that I'm on, we share a lot of information with our customers through Shiny apps as well.
Great. Thank you for that explanation. And it's always great to hear that real world case too, that we're not, again, doing these things just in like the walls of academia, but they're used in real life. And we did mention, I think I did mention it in one of the lessons, but with R, it's like so powerful that we're able to go from something like simple program or a script to something that can be a full-blown application. And so when you're thinking about, and it's probably early to even be thinking about it, but since I have a captive audience, I can give a little bit of advice. And my advice is that, kind of think about who you want to work with and what kind of project you might want it to be doing as part of your capstone project. You'll be working on it for a year as part of this program, and what it is that you actually want to build. And I can explain a few things that I've worked on with my capstone team. So one project that they're still working on, but I'll demo the Shiny app in class when we meet in person. But they're actually working on a predictive model that is able to identify areas of New York City that have signals of gentrification. And they're studying this phenomena of gentrification to as a proxy for areas of real estate that are considered to be growing in value. And this app is intended to serve a few different audiences. One would be a novice investor who's looking to invest in an area of real estate in Manhattan, let's say, for example, or anywhere in New York City, and looking for a good value and what neighborhood should he or she consider. And it would identify those areas of gentrification and then come up with a particular score that would, which would be this score based on other data that signals gentrification that they have used in their predictive model, which could include things like Yelp restaurant reviews. And you'll say, Yelp restaurant reviews, what does that have to do with gentrification? Well, so we're in a business analytic program. We are dealing with a changing world in which, data has become so much more accessible. It's definitely become bigger, but it's much more that it's become much more open and accessible, and that we have the ability to look at Yelp reviews that show, signaling more people and more energy in a particular location where there's particular sets of restaurants and businesses. And so once you start seeing things like cafes and restaurants popping up and people actually going to them, that's one signal of gentrification. But there's many, many others. And you could also look at data from, say, Zillow or Trulia or other real estate databases that could signal that. And so what they've done is they've many, many data sources to come up with a interesting predictive model. And so I'll demo that app in class, but it's just so exciting what's possible. And they're able to create like a full-blown web app using Shiny. So they're able to do their modeling in R and also do some of their development for the actual application in the same environment, which has been terrific. So it's not only a tool for your kind of back end, getting your models or your answers or to do your analysis, but it could also be a front end tool. And I'll show some other examples of that in the next few minutes. One of the things I just want to navigate to is my my PowerPoint presentation. Let me just bring up another window here. So this is just another example. So I mentioned a little bit about Shiny, and Shiny is great to build these different interactive interfaces. So it's basically a web application framework. So I wanted to give you kind of just a general definition. So you can build things that look like this. So you might have seen, this is an example of a simple app that was done in Shiny using movie data. And guess what we're using today? We're using movie data for one of our exercises. So you may say, well, okay, we're calculating summary statistics and making simple graphs. Well, we could actually start creating interactive graphs with not that much more work than we're going to be doing today, okay? A lot of it has to do in the pre-processing of data, making sure our data is in the right format rather than just the presentation of that. This is just one example. This is an example of a Shiny app that was done by my students, another capstone group, who put together a marathon training app. And based on who you are, how old you are, how much you weigh, your fastest 5K time, how many miles per week you're averaging now, and how fast you're running those miles. And based on that, you get a report and an output and a training plan and different training tips based on this. And so, and even a predicted finishing time. So my predicted finishing time was very slow, five hours, based on me running like slow miles. I think I might have been pregnant or something at the time. I don't know, but I was running slow. So this training app is pretty amazing, and it really meets a market need that's not necessarily available now. So there's a lot of apps there that are not so customizable and that don't draw from multiple data sources, and they're pretty inexpensive. And then there are coaches who can train you for marathons that are very, very expensive. And so this is an app that kind of meets something in the middle, where it's much more customized than any of the other products that are out there on the market now. So does this run on a web server or only within RStudio? So you can buy space to run this. When you have a Shiny app, you can run it through like the RStudio interface, and then you need to publish it, and you can publish it on some of the options for RStudio. There's places where you can publish. You only get a certain number of I don't know if it's minutes or space or something like that. I think it might be in terms of uses, like how many times you can actually use the app that you publish, and then you have to actually buy space for it, but you can get a server for it. My students are running into that right now. So I just wanted to kind of show you that, just to kind of hopefully inspire you for you to see where you can go with this. And that was just a very, very simple app. One of the things that I'm working on for this class is creating some pretty sophisticated documentation for our exercises. So as you know, with our Markdown files, like this is an example of an R Markdown file that we're looking at, and we'll be working with this. We're going to be working with some bike sharing data in the on-site class. And we're going to be able to create some interesting visualizations, and also not only have this as an R script, but create our own R documents. And we can create several types of documents in RStudio. So right now I'm looking at an HTML one that I'm able to format my text. I can actually have some of my code here. I can have my output. And if you started creating your R Markdown files, you can see that this looks much better than your R scripts, right? And it actually gives you some preview of what we're looking at. I can create really nice tables, and I'll just show a few other things here. You could also embed your, we'll start creating things like density plots. We'll look at our good old histograms, but we can also start creating more sophisticated visualizations like scatter plots with regression lines or Loess lines, right? So, and then we can use other types of packages, like aside from our regular graphics package, to create more high quality visualizations, and we could also do some filtering as well. So if I was looking at this, and if this was interactive, I could actually create this as an interactive graph, and we'll do that as part of the R class. We'll create some interactive graphs, and that will be using a package called ggviz and then a package called Shiny. So we'll do that in class, and we'll be able to do some filtering. We could also do some nice color coding. So if you've been creating some graphs and they haven't been looking that sophisticated, we'll definitely get there. And especially in the data visualization course that I teach, we do a lot more of that, and we use other tools aside from R. But I like to kind of show some of the different tools that you can use for exploration of data, because this is really the point where you're not necessarily looking to present, but more looking to explore your data. And data visualization is part of that process. So you begin by understanding your data, looking at, say, the data dictionary, looking at maybe doing some pre-processing, and then getting all the way to the point of doing some, getting some basic understanding of it through visualization. Like what do the variables actually mean? Are there any relationships between them? And so on. What does the data look like over time? And then how do I devise questions that can help me further investigate my data now that I've gotten to this point of really understanding it and doing some initial analysis. Now it's time for me to ask some harder questions, like the ones that I have highlighted here. And then we'll also go through in class a case example of looking at some data from Epicurious. I got some feedback from the class that looking to work with some of this data that I'm working with from Epicurious. This is a recipe site and how people rate recipes. So we'll be working with some cool data, some bike sharing data, some Epicurious data, and ask some interesting questions of that. So what I'm showing you here is everything that's been created. It's all been created in R. So, and if I close this document, you'll see that this is my R document. And it's my R Markdown document where I can have a few things here. So I can have a lot of, plain old text, which is fine. Always words of advice from me, and I'm working on some things here. And then I can also have my headings. So my first heading is understanding your data. And then I show, I show how we import our data, and then you can see the output there. And then I can have another heading and some plain old text in my R Markdown. And then I can have my R snippet here. And you just do your R snippets in your Markdown file by saying insert R. So hopefully you've gotten to that point already. How many people have created an R Markdown document? If you have, just let me know in the text chat, just so I can see, okay, so I see like 5, 7 people. Yeah, one of the assignments. So the possibilities are really amazing for working with R. If you look on the right-hand side here, you could even create PowerPoint presentations. So here is an example of one that I'm working on for the bike share data set. And I can actually embed plots, code, and other elements into a PowerPoint presentation that I can then, show full screen in class, show at a conference, but then actually have my, things like my graphs and my code formatted, in a way that is a natural output of R and doesn't take a lot of additional processing, which is great. So we can use our R scripts to write our programs, to analyze our data, and then we can format those R scripts into R Markdown documents, like the one I just showed you that we're going to use in class that have, some, that are, kind of cast in a narrative, like you might write a report, for instance. And I can actually have data there that is live, and code and visualizations that are embedded. I can show the code. I can choose to show the code or not show the code. So there's a lot that you can do with that. You can also create presentations like I just showed you. And if I have this up, I wanted to show you one more thing. There's actually a something called Bookdown. Has anybody heard of Bookdown? So Bookdown is yet another package in R. And right now what I'm looking at is actually a book on Bookdown. And it allows you to create, very simply, this is the book that you can buy, but it's actually available for free online. I can give you the URL if you're interested. Actually allows you to create a book that's online. So this is the table of contents here. And to also utilize a lot of the features of R Markdown, so you can have your code presented very nicely along with other text. So you imagine using Bookdown for maybe even your capstone project, for instance. It's very nice. You can have references, URLs, and it's a great way to, if you're using GitHub and setting up your work in R as a project, which I'm going to show you in a second, everybody will be able to collaborate on it because it has version control. So I'm especially motivated using Bookdown because I'm writing a book. So I'm writing a book called Becoming Visual, and I think I mentioned it to a few of you, but it has a lot of visualizations that are going to be created in R. And I also want to have an online version of that book, and most of the visualizations that I think are really explain exploratory data analysis I can do in R. And the nice thing is that I can show my readers the code if they care about it. My book is meant for a wide variety of audiences, but for students in particular. And so the students I know want to see the code. And so being able to have that available is going to be great. So any questions? Okay, well, I hope this is interesting, at least, or I did want to share that with you. Okay. So I'm going to go ahead and move back to my first PowerPoint. Just bring that up. So we're going to work on graphs today and just some basic points about visualizations in R. So one important thing, besides being able to do it, which I know is a great starting point, we want to be able to build them, and we want to know how to use the various functions that allow us to build visualizations. So real quick, what are some functions that allow us to build visualization? For histogram, box plot, histogram, great. Plot, ggplot2, Scatter plot, okay, good. And so these functions, a lot of them come from different packages. So what scatter plot comes from what package, Akash? And Mon, what packages plot come from? So scatterplot is one that that comes from CAR, right? Lynn, you're right. So applied regression, the CAR package, good. ggplot is where we use a function called ggplot2 to create various visualizations. There are many packages in Psych many functions in Psych that allow us to create some plots as well. And the plain old plot function comes from the graphics package in R, which is like by default. So we want to be aware that we are getting in the world where we need to be installing packages a lot. And because we're going to be doing a lot with visualization, and there are certain packages that work well. And so getting in the mode of easily understanding how packages relate to the functions that you need to use is a really key thing I want to make sure that you have and you're comfortable with by the time you come to class. Because before class, I'm going to send an email and I'm going to say, make sure you have these 10 packages installed before class, okay? And so that will happen like in like May 10th or something. I'll send an email and just make sure everybody has those packages installed that I'll be using. But I want you to know the relationship between packages and functions, okay? And then that's just going to be important because then you'll know where to find documentation. Because if you know what package you're talking about, all documentation is really around packages, okay? And then those functions within those packages. Good. Okay. Thanks for your participation. So one thing about visualizations is we want to make sure we can make them and how to make them. But the output in itself needs to be self-explanatory to some degree and make it easy to understand your data. Now that is a bullet point here, but that is an entire process. Like we're having a whole course that deals with number one, okay? It is not easy to go from exploratory data analysis to using a visualization for presentation. It might be technically easy, but in terms of I create a graph, I show it to you. Do we both find the same meaning in it? And if the answer is no, then we need to figure out why and how do we revise that so it's clear to you and me what we both should be seeing. David Edwards, love it. Ever Tufte's books are great too. Absolutely, it's one of our required readings. So we're gonna read one of the Tufte books. A lot of his books are for presentation of information for print, and so we'll be looking at some also contemporary texts as well. His are very foundational, which is terrific, and he's considered the grandfather of information graphics. And we'll look at some studies that look at his work and praise it, but also critique it. So we'll look at both sides of the coin with that. We'll also look at visualization as a tool for both data visualization, for presentation and exploration. Okay, so that we want to know that it's not the same thing. When you show me a box plot, I bet when you give a presentation to a layperson doesn't know your data that well, that box plot's not going to have that much meaning. Or when you show a scatter plot matrix, or when you show histogram. Okay, those are visualizations that are don't show them to anyone except yourself and your analysis team. You want to kind of move beyond those visualizations for analysis into ones that are much more reveal themselves and can be easily understood by your audience, if that's your intent. So that's what we do in the class, the visualization class. Now we're just working on exploration. Visualizations obviously are very easy to show how well variables are correlated. There's some science behind the idea of, while we're doing exploratory data analysis, that it's necessary to both analyze it statistically, but also to visualize it. Okay, because sometimes when we look at summary statistics, it doesn't always reveal everything to us, just the numbers. Actually, visualizing the relationship can tell us a much better story at times. It's in addition to, not as a replacement. And then, like I mentioned before, there are several packages. Here are some that, these are probably the ones that we'll be using mostly. And I would probably add Shiny to that as well. I like to always talk a little bit about a few types of visualizations too. So when you draw histograms, this is always the difficult part, is knowing to determine where the breaks are to separate the bins. That's important to know. And then one other final thing about box and whisker plots, that these show the median, that's that dark line in the center usually, not the mean. Okay, and so sometimes people get those confused. And I've been teaching this long enough knowing that when I ask, what does that dark line mean in the box and whiskers plot, half the people think it's a mean and half the people think it's a median. And they're in a class that's doing data analysis. So I'm making this point because imagine showing that kind of visualization to an audience that doesn't even know your data, that you'll probably at least get half and half of the people that are, don't know how to interpret that type of visualization and what those encodings mean. Good. I mentioned a little bit about R Markdown, but I have this, this is from the documentation, but when we're creating R Markdown documents, they're amazing because we can actually create documents that have our visualizations that are embedded with our code and with text. Otherwise, we're just kind of executing our code and we're seeing our visualizations in RStudio, but then they're kind of gone. So this allows us to kind of create a report that has all our visualizations in there, and then we can keep running that report as those visualizations get updated. So we start with kind of an Markdown file, which is .rmd. So moving away from writing R scripts, you can start writing R Markdown files if you're comfortable with that. And then this allows you a lot more freedom because you can you use the syntax and you can write a report, you can embed plots. Okay, and you can also show input and output together. And then finally, you can decide when you want to replace code, the R code. You don't have to show all of your R code at at all times in the report itself. It can be shown in the R Markdown file, but not necessarily in the output. And then you can produce nice reports, which is great. And then those reports can be, exported to HTML. You can create a slideshow. You can create a PDF. You can create a Word document. And then you can publish those, which is amazing. So it allows you to kind of go start to finish. We don't start with R Markdown files because we start at the very beginning with R. And if we did R Markdown files, you would never know what an R script was or how to just work at the command line. So that's why we evolve in what we're able to do in this environment. As always, the solutions are posted. I updated the solution for for exercise 6. So just if you looked at it beforehand, I had a bug in it. So I fixed that. So you can go ahead and these links are also posted online. We're probably just going to go through the first exercise 5 today, as always, and then you can take some time to go through exercise 6, where we do some really cool like faceting, plotting graphs, multiple graphs on one display, which is pretty cool. And we create some different types of graphs as well. But I like to take the next 50 minutes or so to really go through some of this stuff in detail. Okay. Any questions at this point? All right, I have one more thing that I want to explain to you, and then we will get to exercise 5. So please make sure that you have that exercise available to you and you have the data. As a reminder, it's always available in the materials tab. We're working with a data set called movies 2014.csv. And I just asked if you have your mic on. I'm just going to mute everybody's mic because I hear some just noise in the background. Thanks. Okay. So, as I mentioned, I use R obviously for my life. No, I use it for a lot of different things. And I'm using it for this book that I'm writing called Becoming Visual. So this is like my kind of environment here. I'm just gonna like save everything. And I also have this very important class that I'm teaching, Foundations of Statistics Using R. And I do these live online sessions. You might know about them. And what I do for those is I actually have a project for this course. And I have that project in my RStudio environment. And what does that allow me to do? Well, by using RStudio, in addition to the feature that allows you to create a project, it allows me to never have to set my working directory. Remember, we spent lots of time working with setting our working directory and things like that. And it kind of lets me save the place where I left off. So I was working on a lot of different data sets here, as you can see in my global environment, and they're here as soon as I changed to my project. I was in this project called Becoming Visual. Now I'm in this project called Practice Exercises in Process. A lot of folks that have their code that's very open and want to do tutorials will even have their work as a project. So I'm looking at this Bookdown, which I mentioned before, which is this package that allows you to create books in R. So I have the tutorial here that I'm going through, just as an example. But so when you're in a project and you create one, I'll show you how to create one in a second. But the great thing is, like I said, it knows what your working directory is. It knows where to find all your files. And if you go to this Files tab, all of a sudden this Files tab is very, very useful because it's everything that's in my working directory. Okay, so I can actually look at my, I have all my movies data, everything, all my code here. That's here. I can create a new folder. I can organize things here. I can rename things, which is really nice. So that's just why I like working with projects. And it also allows me to, publish my projects if I want on GitHub, which could allow for then sharing. Say if I was working with a team on a capstone project, I would probably create a project in R and then check in all my files on GitHub, then allow for easy version control and checking in and out of code that you're working on with your students, your colleagues. So how do I create a project in R? It's pretty simple. So File, New Project. I'm not going to go through the whole process, but you can either choose to use an existing directory that you have or create a new directory. So if you create a new directory, you can decide if you want your project to be your own package. So guess what? You can create your own packages in R. So you don't have to be, somebody that's been working in R or Coder for 10 or 15 years. If you've done something cool, you can create your own package and publish it on GitHub and then contribute to the community. And wouldn't that be like an interesting thing just to add to your resume and then to gain visibility in a community? You can also create an empty project or a Shiny application. So you're probably going to create an empty project, and then you just basically give it a directory name and choose the subdirectory for it. And again, you can create a Git repository for this. So I would encourage you to create at least a project for all the work that you've done in this class. So then it's all grouped together. So when you come back, you can say, oh, that's what I learned in the stats class versus that's what I've learned in the data mining class. And you'll be using so many more packages, even ones created by the professor in the data mining class. So having all that organized is really going to help you. So I hope you take the time to do that between now and when class starts. All right. Any questions at this point? So now it's time for you to do some work. So we are going to look at the exercises for session 5. And what I'd like you to do is go through and do the first 4. And if you get through with those, the first 5 questions. And the idea is that we're working with this data that's this movies 2014.csv. I'm going to clear my environment. And what I want you to do, obviously, is, import your data. You can look at your data, look at number of variables with the names of columns. Okay, what are the variables? Look at the dimensions of the data set and do some basic plotting. And then start looking at what's wrong with some of the plots that you create. And I kind of give you some hints on how you can make something like this, which is your base plot for the movies data, comparing tickets sold to the gross sales, how something like this can be improved. So what I like you to do is go through and create some scatter plots and redo those scatter plots and refine them until you get to the point that you have something that looks, pretty good and not like the one I'm showing you. So I don't want to show you yet what I think pretty good is. I want you to show me or tell me what you think pretty good is. So why don't we take 15 minutes to do this? So we'll come back at 11 o'clock a.m. Eastern Standard Time. And I see, Brian, you have a question. So everybody should start working, and I will come back in 15 minutes. And Brian, I will try to work with you on your question. So it looks like you're just having some kind of error with the data file. So what happens if you use read CSV to import? So when I'm looking at the documentation about when it has to do with the readr package when you import using the button, which uses the read underscore CSV. And it looks like in some cases it treats outliers as NAs for some reason. Well, this is at least one instead of as a numeric, there seems to be some issue with it. It seems to have to do with integers versus numeric. I'm going to go ahead and post a link that you can read more about this while you're getting the error. And I'll try to replicate it too. I'm going to do this from another account. Let's see. So you can go ahead and read that. It's from student Brian. I have two machines going here, so then I can always do research. This is one of the reasons why when learning this stuff, it's like when a new package comes out, like they're still like dealing with all the bugs, so not all the answers are known. Dimitri, I see your question about is there a way to delete bad data? It's very general. There's a way to clean up data. And then I would ask a larger question, what makes data bad? Okay, so it's 11 o'clock my time. Does anybody need more time? If you do, you can also send me a private chat if you wish. I'm getting feedback from 3 people. Probably not representative of the entire class. However, I'd like to review this with you. And I would ask that you kind of share your code with me if you are willing to, just to show others how you might have approached solving some of these problems. So where we left off was you've imported your data, you looked at it, you got some sense of the movie's data. What's the top grossing movie? Does anybody know? How would you figure it out? What would be the code that you would do to, besides looking at it, like we're looking at it right now, but what would be the code that we'd use to figure out what was the... We might use the max function, right? Take the max of this column. Good. Okay, so those are some things that are nice to do before you kind of start, just to know what you might be looking at and examining. Okay, good. So some people share their code, great. And it's going to be a lot to read in the text chat, but you can always go back. So we created a simple plot here that you see in the lower right-hand corner called nothing, right? Because there's no title on it even. And so this is one thing that is not great about creating a visualization, is that you want to make sure that you have nice titles, nice X and Y labels, and also nice encodings of your data that make it interpretable, which means that these scales here probably don't work that well. Would you agree? So the next question on part 2 is to redo this scatter plot by dividing by 1,000. So one thing that we can do is we can actually divide the tickets sold and the gross by 1,000. And now we're actually seeing a chart that's looking a little bit better, right? So I can actually see what these actual tick marks mean. However, you can see how my X and Y labels are even getting more cluttered. It's showing me the data frame and then the variable name and then how it's divided by 1,000. Not really a great name for a label. So let's go back. And all I did there, David, that's a great point. Wouldn't it be great to create new variables? Yeah, and that's what we eventually do, right? Because we want to have the names be better. We want to reference them. But as we're kind of just exploring the data, we want to see, like, okay, what happens if we divide by, if we divide by 100,000 instead? And we could see that it's even getting clearer. So if you attach movies, Tim, you don't need to specify the data frame. So you wouldn't have to say movies $. So we're getting better. And that could help us with our axis labels as well, if we just rename our variables to something that is more readable. And the next thing I'm going to do is I'm going to scale by 1,000,000. And what I've done is I'm actually creating 2 new variables here. And then now I can reference those variables throughout. I'm going to just create a quick plot of that. And you notice that my plot this time looks a lot better in terms of what? One is that the scaling looks better because I've divided my tickets sold and gross revenue in millions. And I also, yes, thank you, Akash. So I added labels to the X and Y axis. So instead of using the variable names, I'm using labels. And there's a parameter that you can pass into the plot function that allows you to do that. Lynn, very good, no frame. So now I don't have that black box around it. So I set the frame parameter to what? False. Okay, it's a Boolean. So I set that to false. And then I added a nice title here. I don't think my title's so nice. It doesn't really tell me much. My title could be a lot better. So I want your titles to be better. Going back to my R Studio. So let's just look quickly how I made my plot, the code for my plot. So let's just look up here. So I'm passing in my X variable using the plot function. I'm passing in my Y variable. Main is how I have my title. Okay, so that's if I wanted to modify my title, which I don't think is good. So who has a good title? What should I title this chart? I'll use your title. If somebody has one, type it in the text chat, and I'll add it to. We'll do this real time. And then I also have my X lab, which is the label for the X axis. So I can actually define what that is as a string. I can keep going. I can just define my Y lab, my Y label, and then I can set that frame plot to false. Somebody's tickets sold and gross earnings. Tickets sold and we like to use sentence case for our titles. So instead of using all, capitalizing every letter. So if we run that, let's look and see if this looks any better. I need an S on that. Save it. Okay, looking better, right? Thank you. So then the next question is, well, let's see what the correlation is. And I think we're going to know this before even running the function core. All right, so we're going to see there's a direct correlation. So we're getting a value of 1. And why don't we go ahead and add a line, a regression line to the scatter plot. And so if anybody's done that, you can type your code in the text chat if you haven't already. What is the feature that adds a line? Some people are using different functions. Okay, so we're going to say type B here. Okay, and that's going to give us our line. And I'm going to go ahead and retitle this one as well. You probably want to say tickets sold and say something like in millions. But lots of different ways that we can do this. I'll run my plot and zoom in so you can see, and there's my regression line. I mentioned that there's other types of lines that we can draw, like a Loess curve and others, and we'll learn how to do that soon enough for sure. You probably were learning already in your stat class. In the stats portion of the class. So we have that. So I thought I could show you how we can use that. Essel is using the scatterplot function, and I have an example of that. If you look at Essel's code here, she's using the scatterplot function. We're using a scatterplot function. This is another way you can do this, using the CAR package, companion to applied regression. So if you want to learn more about that package, simply in the console window, I'm typing $CAR, not cars, CAR, singular. And you can learn more about that package. The CAR package is here, the companion to applied regression. And here there are various functions. If you want to learn more about it, you have to kind of dig a little bit. I like using library because it keeps, if you spell it right, it keeps basically in your R environment, it keeps it checked here. So we need to use the CAR package, and because we want to use the scatterplot function. And so why don't I just show you what that function does? It's we didn't have to do much customization or formatting here. What we're getting is our regression line already drawn for us. We're getting a chart that looks like a scatter plot, and we can modify our labels, of course, but we're also getting these box plots on the side as well that show us the distribution of the two variables. So that's one way that we can do it. Like I said, I prefer using library because library basically, instead of the require, keeps it checked here in my environment. So CAR will stay checked next time I open up my project. Okay, it wasn't checked before because I used require. I was doing this as extras, so I think I was doing this real time during one of the classes, so I just used require. Okay, so I want to show a few other things. So scatterplot, that's a function, and you can see that I have the same types of parameters. I have my X lab, Y lab, I have a main, I can set my frame to false, I can pass in my X and Y, and I can modify all of this to look even nicer. Another way that I can create a scatter plot is using a package called ggviz, and this is a package that allows for interactive and animated visualizations. So this is one that you may want to think about. So I'm just going to type the name of the package in the text chat. It's called ggviz. And if we basically, it's you have to start learning this type of syntax, which is this this percent sign and then this greater than sign and another percent sign that separates out it's almost like using a plus sign in some other functions, but it's a little bit more sophisticated, so it allows us to simply use different features and functions of ggviz together. So what this is basically saying is that I want to use the movies data frame. I'm calling a function called ggviz. I'm passing in as my X variable total sold in millions, and as my Y variable total sold gross in millions. And then I'm going to call this other function called layer points, and that's layer points is a function for scatterplot. So if I run these two together, you can see a few things that I find very interesting. Now, I didn't modify my labels or anything. I mean, you have to go ahead and do that. But I just want to show this for illustration purposes, that this renders a chart that is, you can see the clarity in it. And I mean, this is definitely, made for, 2017. It's very clear. You can use this on the web. It has high print quality. And it renders it as a vector graphic. So what that means is that if I make this really large or I make this image really small, it's going to maintain the integrity and the same and a high quality, and I'm not going to really lose resolution. So it's not like the numbers will get pixelated, for instance. So I'm just going to get out of here. You could have just said movies here too. I didn't need to say movies because I already referenced it here. I was just doing this one quick. So I like to show ggvis because of the quality. If we just look over here, so you can see that there's a concentration in the lower right quadrant where my viewer is. There's a concentration of the data points and they layer, but you can still pretty much read the axes. And if I go back and I kind of, let's say if I create this scatter plot, you can see it looks a little pixelated. And if I go back up above, I just use the basic plot function. I mean, you could just see the difference in quality of the images. So this is one of the reasons why I prefer for presentation quality to use ggvis, and that's like a reason for it. Aside from the fact that it allows for this kind of interactivity that you will learn about. Another very popular package maintained by Hadley Wiccan is ggplot2, and I'll write it out just so I said it too fast. And this is one that it'll be important for you to install. And we can create pretty interesting plots using this as well. I'm just going to show you the basic scatter plot kind of out of the box in ggvis. I'm sorry, in ggplot. So it looks a little bit better than the plot one if you compare it, the ggplot. And so I'm going to give you a quick explanation of that. So if we look at my code, how this works is that we have a function called ggplot, which is from ggplot2. We pass in our x, so our x is our data frame, and then we have this parameter that's for what's called like the aesthetics, which basically, as I moused over it, you saw. Let's see if I can get that back. You saw that it's really pointing to my x and y. So it's aesthetic, it's AES, and then you pass in quite simply your parameter for your x and your y. And then you can, as you do that, you see there's an opening paren and a closing paren. And then I have another parameter that I'm passing in, the x and y. And then I use a plus sign and I say geom point. That's gonna indicate the type of chart I want to create. If I remove that and I say geom, I have a lot of different charts I can choose from, as you can see. Jitter, label, line, map. I mean, you can keep going. You can try all of these out. But we're going to use geom line, which is going to render this chart that we have on the right-hand side, our scatter plot. Now you're going to say, well, I want to modify all the titles and everything because we need to do that. So we're going to go on to the next. So how we do that is we're passing in our x, we're passing in our y, and then we're defining that we're using a geom point, and then we use the plus sign again, and we're passing a parameter called labels at labs, and we can indicate a title, tickets and gross. We should probably make that better. Tickets sold and gross earnings. A subtitle, so any kind of subtitle you want, and you can even have a caption, so where the data came from, okay, and that will appear in the lower right-hand corner. And then we can also have a label we just say X, and that refers to the label for the X-axis, and Y for the label for the Y-axis. And on top of it, somebody mentioned Edward Tufte. I can use a theme that allows me to customize the display of my chart and the aesthetic features called themes. So why don't I show you this, and then we're going to go over the themes part in a second. So here, you notice that the aesthetics look much different because I'm using a special theme here. Everything's in like a Times New Roman, and a lot of Tufte's work is really meant to look as if it's designed for print. And you'll notice that I have my title here, my subtitle, I have my labels, and over here I have my caption, datafromnumbers.com. So to show you something else, and then I'll get to some questions, I'm using a package called GG Themes, and that's going to allow me to, like I said at the end here, to choose a theme to apply to my chart. So I use the function theme underscore, and when I do that, I have all these options. So I could make my work look like it came from Excel. I probably wouldn't want to do that, but let's say because I don't think Excel has particularly a great aesthetic. But if I wanted to, this is what it would look like. And I hope I'm getting some chuckles. So it would apply the design for a chart that was maybe designed in Excel. You could even use the Economist design. So instead of so you can make it look like it came from the Economist magazine. Okay. And again, you have to use a GG Themes package to do this. And then I'm getting that kind of blue. You can use Wall Street Journal. You can use Google Docs. There's so many different themes that are available. But guess what? I can only use themes with ggplot. I can't use it with plot. Okay, so that's, again, understanding the relationships between the packages and the functions, and what functions you can use where is going to be really important. So I'm just going to pause for a second. I hope this was useful. Nicholas, I'm glad that you're laughing. Thank you. I appreciate the feedback, even if it's laughing. Saif has some questions. So for every package, does the command differ for the same function? Oh, you mean if it's just named the same? Yeah, it could, totally. So if you have a function called like scatterplot, it might take different parameters for the car package versus, say, another package that used scatterplot like psych or something. Good. Okay. Any other questions? Can you define your own theme? Of course. Wow, that's not like a 2-second thing, but I mean, if you look at how GG Themes was built and the different parameters that it takes, you could simply do that and then call your own function, and that has to do with writing a function. Can you see a data point when you hover over the graph? Is there going to be a pop quiz? Oh, okay. I'm not big into pop quizzes because I don't believe that people learn just in 1 second or 2 hours. I think that it takes practice. So I'm not a pop quiz person. I believe this stuff takes time. Why is stuff in blue and black? I mean, I think these are, usually everything in green is going to be, this is like a comment, but there's a different color green here. It's usually this green refers to the variables. Keywords tend to be blue, but not all. It's a little inconsistent, but it looks like some parameters are in blue. So Hanwha and Alvin, you have given there are quite a few packages which will be mostly ones learn really well. Well, I mean, you should know the basic graphics package, right? So I'm just going to type a few things in the text chat. So the basic graphics package you need to know. Why? Because you're going to want to know how to do simple XY plots using the plot function, right? And so that's just like, and do you need to know it really well? Well, I mean, you need to know that you pass in X, Y, you can pass in a main as a title. I mean, and then you can define your X lab and your Y lab, right? So if you could, like how I'm talking it out, if you could do that, then I'd say you know it pretty well. And then if you know, like, oh, how do I create a scatter plot or something else using the plot function, then you can just look at the documentation and just there's an option for type, right? So if I go question mark plot, I have the option to see type. Like you might not have these memorized. P for points, L for lines, B for both. I mean, you're probably just going to do points or lines, right? So that's an important one because when you're just working with data quickly. Now, as you move on, it's going to be important for you to know ggplot, that package. Why? Because you have so much more flexibility in terms of the types of plots you can create. If you remember, when I went to GeoOnline here, so these are all the types of plots I can create. So if you know how to create one, you're going to be able to know how to create all of them, essentially. You just have to understand how to read the function and know what the parameters mean. So I think that's going to be an important one. And if you want to render high quality graphics, if you want to create things that are interactive, then you're going to have to know ggviz and you're also going to have to know Shiny. So right now, do you need to know the car package, like for that one scatter plot function? Probably not. But just knowing, it's not that you have to know packages in their entirety. You just have to know like what your goal is and to figure out what tool you need to use for that. Yeah. One other thing I want to show is, so I created this ggplot. I'm just going to run it again using the Economist theme. If I want to save it, I can use ggsave. So let me just show you that. ggsave, and I put in what my name of my file is. Where's that file going to be stored? Working directory, right. So I call it my special plot. So I call it my special plot.pdf because I want it to be a PDF. And I run that. It saves my image. I can go in my file section here and I should be able to find it. You see my special plot. I bring that up. There's my special plot. Okay, and then you can go share it with folks. Yeah, you can export it. There's a button to export it, but maybe you're doing a lot of different things and a lot of different work. And so you just, as you write your code, you're just like, I want to save this image. I want to save this image. I want to save this image. You don't want to have to interact with RStudio. So say if yes, you could. There's many different ways you can achieve the same goal in R for sure. So you could simply, when you have the plot up here, you can go to export, save as image, save as PDF, copy to clipboard. Good. Good questions today, everyone. All right. Do we get to use Tableau in DataViz class? No, we totally use Tableau. So you'll get a free license for it. We'll use one of the most current versions. And I do a lot of work in Tableau. We will. It's possible to even import some of your R models into Tableau. We don't spend a ton of time on that because it's not something that people do all the time. But you can connect your R work to Tableau. You can use R for pre-processing. You can use R for creating dashboards, and you can do the same with Tableau. So what about ClickSense? We don't use ClickSense. Here's the reason why. One, it's only for PC, unless they change that. But as of like a few months ago, it was only for PC, and that's not platform independent. Second, you could tell me, but students don't like to learn like 50 different programs or software packages. So, and that's very hard to be an expert at, many things. So we like you to have a really strong toolkit. And if you want to add on to use ClickSense or something for your industry or something, we encourage that. But it's a holy war. Oh my gosh. It's maybe a debate between which one is better, ClickSense or Tableau. I think Tableau has a really, really strong community. So we will be doing a lot of work in Tableau. And believe it or not, starting in September, you're going to start using Tableau for my class because that's when the pre-module starts. So it's going to be, before you know it, we'll be doing that, and then you'll be seeing me in Shanghai. But before that, in New York. So does anybody have any questions? I'm glad that you're excited and psyched. I am. This group is great. We're kind of reaching that time of where the class is over. But if you have any other questions, I'm happy to take them. What I'm going to do is just stop the recording.